video we're going to do just a quick demonstration on how to work with radians and circumferences of circle. So let's start off with just a circle. And what I'm going to do is I'm going to assume that there's my center point, and from here to there is my radius. And for keeping it simple, let's just say that radius equals 1. Okay, and now I know that at the very beginning, the whole idea behind pi is that it equals circumference over diameter. And this is the definition of how one finds pi. If you just take anything that's round, a wheel, a Pringles jar, and you measure it all the way around with a tape measure and then divide it by the diameter, you'll get pi. So when I want to get circumference alone, what I'm going to do is I'm going to multiply both sides by d, and then these two cancel out over here, d being diameter, and I'm left with d pi equals c. And d, of course, for diameter is this whole length right here. So half of that, or two radiuses equal 1 diameter. So we could say 2 pi r, 2 r's right there, give me the circumference, right? Okay, so this is all stuff that you've done in geometry class. How can we apply this to trig class? Well, let's erase this here and then, well, pop up a question. Say we're working on a penny farthing bicycle, the big scary ones with gigantic front wheels, and the pedals are directly connected to the front wheel, just like a unicycle. So suppose a penny farthing bicycle has a front wheel with a diameter of 5 feet. To the nearest tenth of a foot, how far does the bike move when you turn the pedals through an angle of 90 degrees? Okay, well, let's figure this one out. Let's start off with bright red, and we know that the diameter, whoops, that's not a straight line. We know that the diameter from here to here is 5 feet, right? So there's 5 feet. And we need to figure out what the radius is. That'll be a little more helpful at any rate. So the radius from here to here is 2.5 feet, right? Okay, so if I was trying to figure out the total circumference, I know that my circumference is going to equal 2 pi r. And so what I can do though from here is I can say, well, circumference equals 2 pi r. Since my radius equals 2.5, I'm going to do 2 pi times 2.5 equals circumference, and in the end that equals about 5 pi, which is 5 pi. What is 5 pi? 5 pi equals 15.70 feet. That's how long it is around that wheel, 15.7 feet. Okay, now if my wheel rotates just 90 degrees, in other words, if my wheel rotates from this point and it rotates this way, 90 degrees total, how much of the wheel has rolled? Well, let's think of this as a parts and a whole idea here. In other words, what this is 90 degrees of 360. So I'm going to do 90 over 360. That's the portion that rolled. And I'm just going to multiply that times the overall circumference, times 15.7 feet. 90 over 360, that actually is 25%, or 1/4. And 1/4 of 15.7 equals 3.9 feet. That's how far the wheel rolled. For the next question, through what angle should you turn the pedals in order to move forward by a distance of 4.5 feet, round to the nearest degree? What we're looking for is we want to know if we start right there on this mark and the bicycle starts rolling forward, how many degrees will the wheel rotate before the total distance covered in this direction is 4.5 feet? Okay, well, let's set this up the same way we did here, the same setup that we had here, only we're going to use x degrees because we don't know how far we need to rotate. So I'm going to say x degrees over 360 times, and then I'm going to do my full circumference. So the full circumference is going to be 2 pi times 2.5, and then this whole thing is going to equal 4.5 feet. Okay. Well, let's do a little bit of simplification. We want to put 2 times 2.5, so this is going to give me 5 pi. So I'll rewrite this as x over 360 times 5 pi equals 4.5 feet. Okay, now to get x alone, I'm going to divide by 5 pi, divide by 5 pi. Okay, so these disappear, and then I'm going to multiply by 360 times 360 here, times 360 here, and then those disappear, so I'm left with x equals 4.5 times 360, so 4.5 times 360, and then that whole thing divided by 5 pi. And that gives me 103 degrees. There you go.